The final topic of this lesson is inverse trigonometry. What is inverse trigonometry? Let's begin with a review of standard trigonometric ratios. And here they are. Sine, cosine, and tangent are defined by y over r, opposite of hypotenuse, x over r, adjacent of hypotenuse, and y over x, opposite of adjacent, respectively. When this angle theta, acute angle theta, is given, then it is possible to find out all these values and conclude sine, cosine, and tangent values. The other trig values are just reciprocals. Now, how do we go backward? Say, for example, sine value is given. What's the angle theta? Or cosine is given. How do you find out the angle theta? When tangent is known, is it possible to find out angle theta? The answer is yes to everything for acute angle case. In general, no, but in acute angle, yes. The reason? Well, this topic will be elaborated much further a couple of weeks later, but here's a rough preview of what's to come. It is possible to express the sine value, cosine value, and tangent value based upon different angles. An angle is running from 0 to pi over 2, and sine value increases from 0 to 1 like this. Cosine value decreases from 1 to 0, and tangent value increases from 0 to infinity like this. Remember, tangent function is undefined at pi over 2. We have vertical asymptote, and consequently we have blowing up to infinity. Nonetheless, all these functions, all these graphs pass the horizontal line test. They're all one-to-one functions, so it is possible to consider the inverse functions, which we call inverse sine or arc sine, or inverse cosine or arc cosine, inverse tangent or arc tangent. All those expressions are equivalent. Well, how do you actually find those out? Well, here's an example. What is tangent of, say, pi over 6? Is 1 over square root of 3. How about arctangent of 1 over square root of 3 pi over 6? You can go back to the angle from inverse trigonometric functions whenever we begin from acute angle. Of course, handheld calculator will not have something like this. You'll have to go to second floor and then look for this kind of notations there. I'm using Mathematica, so things are a little bit different here. And of course, for handheld calculator, make sure your angle is set up properly. If you want DMS angle, set your calculator to DMS measure. If you want radian measure, then set your calculator to radian mode. Okay, let's begin some examples. Find the exact value, arc sine of 1/2. Just use your calculator, and then you have pi over 6. Of course, there is better way, and better way is to draw 1 square root of 3 2 triangle. How about arc cosine? Arc cosine of square root of 3 over 2. Run your calculator, is pi over 6 precisely. Of course, there's better method. Draw a picture. Draw 1 square root of 3 2 triangle appropriately, and then you can find out the angle. Arctangent, well, it's pi over 4. There's graphical methods too. Draw 1 square root of 2 triangle, and you can see that the angle is 45 degrees. Application problem? Okay, alright. A lighthouse is located on an island 2 miles off a straight shoreline. Express the angle formed by the beam of the light and the shown line in terms of the distance d in the figure. Estimate the angle theta if d is 1.6 miles. Okay, instead of the previous examples where the angle was given, this is backward. Looks like the opposite is given and adjacent is given, and you have to find out the angle theta. Alright, opposite is 2 miles, adjacent is 1.6 miles. What is the trig ratio associated to opposite and adjacent? It is tangent. Tangent again. So tangent of theta is 2 over 1.6. D is 1.6. So arctangent of 2.0 over 1.6 and run your calculator, and this is what you get, 0.896 something in terms of radian measure. Let me check. 2.0 over 1.6. Yes, this is radian measure. In terms of DMS measure, you have to multiply 180 over pi, and that's gonna be 51.34 degrees, approximately speaking. Let's see. In this problem, the problem did not specify which measurement, so anything would have been okay, but my preferred answer is both radian and DMS.